In Chapter 2, we're going to start looking at matrices in their own right. In Chapter 1, we use them really just to represent systems of linear equations. But we're gonna look at matrices themselves and operations we can do on them. And so first up, when are two matrices equal? Well, in order for two matrices to be equal, they have to be the same size and all the corresponding entries have to be the same. Another way you can say that is, in order for matrices A and B to be equal, they both have to be m by n. That implies that they're both the same size. And A sub ij has to be equal to B sub ij. All the entries have to be equal for all the valid values of I from 1 up to m and j from 1 to n. And usually this isn't, two matrices, they have to be the same to be equal. The only place where that might get confusing is something like this, where you've got a couple of matrices that are just full of zeros. But those are not equal to each other because they have to be the same size. The second example here, it says find A, B, and C. Well, if we're told that these two matrices are equal, then here, this entry and this entry have to be the same. So A is 3. Let's see, B has to be 4. And C has to be 2. So not a whole lot going on really with those two examples. So let's look at matrix operations. With matrices, you can do addition, subtraction, multiplication by a scalar, and multiplication of two matrices by each other. Multiplying two matrices together is more complicated. The others are really, really simple. First up, let's look at scalar multiplication. A scalar is just another name for a single number as opposed to a vector or a matrix of numbers. And for us, when we talk about scalars, we're pretty much always going to be talking about real numbers. But you could use complex numbers for scalars as well. And to multiply a matrix by a scalar, you just multiply every entry in the matrix by the scalar. And by the way, this is a typo. Scalar in this sense is spelled S-C-A-L-A-R. All right, so if this is A, then the matrix 5A would be 15, 20, 0, and negative 10. So not much to that. Just multiply by every entry by the scalar. Typically, you would write this as 5A. I guess it'd be okay to write it as A times 5, but usually you wouldn't do that. You'd say 5A. All right, matrix addition and subtraction is simple. You can only add or subtract two matrices together if they're the same size. And if they are the same size, you do the addition or subtraction just by adding or subtracting the corresponding entries. So I've got several little quick examples here. If we did A minus C, let's see, what size is A? A is 2 rows and 3 columns. So this is a 2 by 3. And C is also a 2 by 3. I mean, honestly, we don't really have to think about what the actual size is. We can just look at it and tell those are the same size. So we can do the subtraction. And we're going to do it piece by piece. So this is going to be 1 minus negative 1. Then 3 minus negative 1. 4 minus negative 1. So that gives me 5. Then 4 minus 2. 5 minus 2. Negative 1 minus 2 gives me this. So that's A minus C. All right, 5D plus B. So if we wanted to, we could write this out in a couple of steps. Whoops. Let's see, 5D would be 0, 0, 500, 500 plus B, 3099. Sorry for the poor penmanship there. You add this together, you get 30509, 509. Let's see down here. Negative 2c. Well, that's just a scalar multiplication. So that's going to be 2, 2, 2, -4, -4, -4. And lastly, a plus b. Well, those are different sizes, so this is undefined. In order to add them together, they have to be the same size, so that one's undefined. And that's pretty much it for matrix addition and subtraction and scalar multiplication.